My dear students, today I am going to teach you a new chapter, interpolation. Interpolation is the technique of filling up intermediate terms of a series. Here we find two types of variables, dependent variable and independent variable. It is the method of estimating the value of a function for any intermediate value of the independent variable when the values of the function are given corresponding to a number of values of the variable. For example, we are given the production of tea in Assam for the year, suppose 2000, 2005, 2010, 2015, 2020. And we are required to find the production of tea for the year 2002. This can be done with the help of interpolation. Let fx naught, fx1, fx2 up to fxn are the values of the function fx. For different values of x. The method of finding the value of fx for any value within the range x0 to xn is known as interpolation. Now, I am giving you the assumptions of interpolations. There are three assumptions of interpolation. Number one, there are no sudden jumps or falls in the values of the function during the period under consideration. Number two, the rise or fall in the values should be uniform. And number three, there is definite and stable relationship y is equal to fx. There is definite and stable relationship y is equal to fx. And these are the three assumptions. Now, I am going to teach you method of interpolation. Methods. There are mainly two methods of interpolation. Number one, graphic method. And number two, algebraic method. I am going to teach you some algebraic formulae and its application. First algebraic formula is Newton-Gregory's forward interpolation formula. Newton-Gregory forward interpolation formula. You are required only statement and its application. Now the statement is, let let y is equal to fx be a function where x is independent and y is dependent variable. X is independent and y is dependent variable. Let the observations of the function y is equal to fx for x0, x1, x2 up to xn be y0, y1, y2 up to yn. The values of x are equidistant with an interval of differencing h. The values of x are equidistant and with the interval of differencing is h. Then the formula is given by y is equal to fx is equal to y0 plus u into delta y0 plus u into u minus 1 divided by factorial 2 delta square y0 plus up to u into u plus u minus 1 into u minus 2 up to u minus n minus 1 divided by factorial n into delta to the power n y0. And this is the Newton's forward interpolation formula, where u is equal to x minus x0 divided by h. X is equal to period of interpolation minus x0 first argument divided by h. This is interval of differencing. This method is applicable only when the values of x are equidistant, and this formula gives the good estimate value lies in the beginning of x series. So it is called forward interpolation formula. Now I am giving you an example. You see, the example is find F14 from the following data. The values are x and fx 12, 16, 20, 24, and the values of fx are 1, 5, 10, 70. Here the F14, we must calculate F14. This is F14. 14 is the middle value of 12 and 16. Now we use Newton's forward interpolation formula since values of x are equidistant. You see, the values of x are equidistant. Here the interval of differencing is 4. And 14 lies in the beginning of the x series. This is the middle term of 12 and 16. So we use the formula y is equal to fx is equal to y0 plus u into delta y0 plus u into u minus 1 divided by factorial 2 delta square y naught plus u into u minus 1 into u minus 2 divided by factorial 3 delta cube y naught. Here u is equal to, we calculate u, this is x minus x naught by h. Our x is 14 and x naught is 12, 14 minus 12, and h is 4. Therefore, after calculation, we get 0.5. Now, we construct a difference table. You see the difference table is x, y is equal to fx, del y, del square y, and del cube y. We put this value 12, 16, 20, 24. Y is equal to fx 1, 5, 10, 17. You see del y 5 minus 1, 4, 10 minus 5, 5, 17 minus 10, 7. Next 5 minus 4, 1, 7 minus 5, 2, and then 2 minus 1, 1. And these are the leading terms 1, 4, 1, 1. Now we put here y is equal to fx, this is f14 is equal to 1 plus 0.5 into 4 plus 0.5 into 0.5 minus 1 divided by factorial 2, this is 2 into 1 plus next term 0.5 into 0.5 minus 1 into 0.5 minus 2 divided by 3 factorial, this is 6 into 1. Now, after calculation, we get 1 plus 2 minus 0.125 plus 0.625. And our answer is 2.94. This is our answer. This is the interpolated value for F14. Okay. Thank you.